In this lesson, we're going to be talking about secant lines, tangent lines, and how that relates to different angle measures. A secant line is a line that intersects a circle at 2 points. So a tangent line touches it at 1 point and just grazes it. A secant line goes right through the circle. It may go through the center, it may not. If it doesn't go through the center, we still have a relationship between these arcs and the angles formed. We know that these two angles are going to equal because they are vertical angles. The arcs, however, are not the same, but there's a relationship here where this measure angle 1 is going to be 1/2 of the sum of those two arcs. Okay, so it's going to be 1/2 PR plus QS. It's going to be essentially the average of those two. So here, if I want to find this angle, that's going to be 1/2 of 30 plus 55, which is going to be 42.5. So you try the next one. So we add 40 and 52 divided by 2 or multiply by 1/2 to get 46. Okay, next, if I have a tangent line and a secant line that intersect, we still have arcs that are formed, and there's still going to be a relationship between the angles formed and the arcs. So the measure of XTV, this angle, is going to be 1/2 of the arc that it's intercepting. So this is going to be half of arc TUV. Okay, because it really is technically an inscribed angle because its vertex is on the edge there. YTV is going to be 1/2 of TV. And this should kind of make sense. If I were to add this angle and this angle, we'd get 180. If I were to add this arc and this arc, I'd get 360. So it makes sense that the angles added up will be half of what the arcs are. So if this arc is 220, this angle is going to be half, or 110. You can try the next one. If we have the angle, we're going to double it to get the arc, which is 148. The last case is if two secants intersect outside of the circle, then they form a measure. So we're looking at this angle here, P. It's going to be related to both this arc and this arc. The calculation is going to be 1/2 arc BE minus arc AD. So it's going to be the outside arc minus the inside arc. All right, so let's look at some of these. So the angle here, angle 1, is going to equal 1/2 of the outside arc minus the inside arc. So 80 minus 40. So 80 minus 40 is 40. Half of that is 20. Here, I'm finding this arc here, JP. So I'm just going to label it as X for my equation. The angle 20 is equal to 1/2 of the outside arc minus the inside arc, which is our unknown. So I'll multiply both sides by 2, which gets rid of the 1/2. Okay, so if 70 minus X is 40, X is 30. Okay, this next one's going to be similar, but it looks different. So 50 is going to equal the outside arc minus the inside arc. I'm trying to find ln, so I'm going to label that X, but I don't have a measure. But I do know that this arc and this arc are going to add up to 360. So this arc is going to be 360 minus whatever X is. So my equation, 50 equals 1/2 of the outside arc, 360 minus X, minus the inside arc, X. So I can double it to get 100 and then combine like terms. So negative 260 equals negative 2x. So x is 130. Okay, so you can do the last one. So we get 1/2 of the outside arc minus the inside arc, so 160 minus 80, which gives us an answer of 40. So that is secant lines, tangent lines, and their relationship to different angle measures.